This video is a real-life coding example in 3 different languages. To view this week's lecture on programming methods, click here. And to watch this week's lecture on computer science beyond just normal programming, click here. Okay, so I want to point out that we've done 6 videos. This is technically the 6th video that we've done together.
Is it really?
But the first one was an introduction video where you just sort of sat on the counter and didn't do any actual coding. So we have done 5 coding videos, including this one. And I just want to point out how complex we are already getting. And these are all things that we've talked about. You've learned how to use all these things. And we're already up to almost 50 lines of code.
How'd that happen?
Okay, we're at 40 lines of code, just about. And because it's really easy to get lost in all of the code, I wanted to add something to our exercise that will help everyone be a better programmer. So you've noticed I've added a lot of green lines. Mm-hmm. These green lines in here, these are all comments. Oh, so they're just instructions. They're telling you what the next line of code does.
Because no one wants to run through and say, okay, let me run through hundreds of lines of code and try to figure out what on earth is going on and what means what. Exactly.
So instead of going through and walking you through all the code that I've already written, man, I don't pronounce my T's at all. Written. So we're going to go through and we are going to let you read off what the code does and kind of explain it to me. And then you'll be really familiar with the code and hope that my comments actually make sense to you. Okay?
Wow. It's not like I've been actively doing this recently. This is just every now and then that I do this. So, we're at the top. Okay. Set libraries and namespace. Okay, so this right here is just saying these are the different terms we'll be using and pulling them from a library so the program knows where they're coming from.
Exactly.
It's making some of these things make sense if they're not already like a part of the original.
The native code.
Yeah, the native code.
The primitive to the language is one of the ways that we would say that.
Oh, I like this. Okay, so obviously this is where the program's officially starting, right?
Right, line 5, line 6.
6-ish.
Mm-hmm.
Okay, so setting up variables for future use. I like this because here you're saying these are the variables we're going to be using in this program. So if you have a question on a variable and what it means, you can go back up to the beginning and see it. Mm-hmm. So we have base number, exponent, temporary number, answer, and go again.
Mm-hmm. And just a side note, you do not have to use the temporary number in this. But the way I did it, because I went through and I coded everything and then I deleted my code out that we were going to add in here. I found that the temporary number made it more readable. But you might find an answer that would be better than using the temporary number.
Okay,
so
that's good to know.
Okay.
Display title to the console. Okay, I like that. EC exponent calculator. So, remind me what this is right here.
Sure.
Slash n space.
So the \n is the new line character.
Yeah.
And so that's like hitting enter on your keyboard. So we're going down a line, and then I put a bunch of underscores right next to each other, so that it kind of creates like a horizontal rule. We're like underlining the title.
Oh, okay.
Yeah.
That makes more sense. I was like, why is it so long? Do I need to do that? Okay, that makes sense. Build a loop that asks user if they want to do another calculation.
So this is kind of a common convention and some IDEs actually will recognize anytime you write the word to do.
Oh.
But if you write to do, that means this is something I'm going to come back and do later. Or this is something that I need, Mike over in the input-output department over there. I need him to go do that.
Is that a real department?
No, not at all. I made that up entirely.
That sounds really sad, actually. I'm in charge of inputs and outputs.
Yeah, but this specialist over here is going to need to do this part, and I can't do it, so I'm going to write this to do tag in there. So anyway,
Okay.
that's what that is.
Okay.
So my plan was that you could work on this in 2 steps, and you would complete the to-dos.
Okay.
Okay.
Get base number from the user. Okay. It's pretty self-explanatory. So prompts the user to enter base number, and then it shows them what they put in.
Mm-hmm.
Get exponent from the user. So asks them to enter an exponent and then displays the exponent. Okay, step 1. Write a loop that takes it, and this is where we start.
This is where we would start officially. You're right.
Step 1. Write a loop that takes the base number and multiplies it by itself as many times as the exponent requires. Okay. Output answer to the user. Okay, so do the math and then show the user.
Mm-hmm.
So, put out the expression.
Mm-hmm.
In other words, base number, exponent, evaluates to answer. Okay. Are we going to be doing more with this one?
Mm-mm.
No.
No,
I
that's
figured
it.
that one looked complete.
Yep.
Ask
Everything else is
user-
complete from here on now.
Okay. Ask user if they want to enter another calculation. Do you want to enter another calculation? Enter yes, Y for yes, or any other character for no. That makes it easy. And then go again. Okay. And then state end of calculation.
There you go. You
That's
have
it.
just read like 40 lines of code without actually having to read any of the code.
Which makes life easy.
Yeah, exactly. So comments are really useful when you're working in a group, or if this is something that you're going to code and then not come back to for like 3 years. It makes it so that you don't have to rack your brain trying to read the code and anticipate what the computer's doing next. You can just, this is why I did this. And so a good programmer is going to kind of write a book along with their program so that you can just read it like a book. So that's really a good sign of a good programmer is someone who leaves a lot of comments in their code. That makes sense.
Otherwise, it's a nightmare for everyone, and if they go back to their code months later, they might not even know what's going on.
Exactly. And there is a balancing act between making it concise and understandable and, like, verbose enough that it actually, like, makes sense. So that's a balancing act as a programmer.
I get that.
Okay, so let's talk about the math. Since this is not a math class, let's talk about the math behind what we're planning to do here. So if you look at a textbook, this is what it's going to tell you. Like, here's your base number, here's the exponent, and when you plug that into your calculation, you're going to get 32 out of it, right? What that's really saying is 2 times 2 5 times. So 2 times 2 times 2 times 2 times 2 equals 32. The way I did this I don't even remember the first grade where we talked about exponents, but what I would do is I'd say, okay, what's 2 times 2, and I'll take that and move it down here. What is 2 times 2? That equals 4. Okay, I can figure that out. Now I'm going to need to do that. Let's see. That's 1, 2. I've done it twice. Now I need to do it 3 more times. So I have the 5. So I'm going to take my 4 and carry it down. And I'm going to add another 2 to that. Right?
Mm-hmm.
And that gives me 8. And then I'm going to times that. And this is a very repetitive process. This right here, we could put inside of a loop and have it do all of this math for us. There is one thing to note here, though. When we're working with exponents, we don't go through this 5 times. We're going through this 4 times because the first time we're doing this number times itself. So it's a little bit confusing like that.
Yep, that's true.
So what we're going to do is we're going to write our first algorithm to do all this math for us and throw it inside of the loop.
Okay.
Okay?
Mm-hmm.
I guess the algorithm's part of the loop. Okay. Okay, so first let's add in the loop that does the math for us. Now I added a temporary number in there, temp number, because I found when I did it that made it a little bit more readable. Technically you could keep on, in fact if I pull that sheet back up, well I'm using temp number to store this number. Temporarily, that's my running total. You know, if we were to go through here, my temp number is going to be the sum total. You know, say when you think about this, you think about these two first, and then you're going to add on this one, and then this one, and this one. The temp number is going to be the running, I want to say sum, but the running answer.
Okay.
Gotcha. Okay.
That makes sense.
So anyway, that's what's going on with temp number. So what I would do first is, because the first time through, we're going to want our we're going to want to multiply. We'll go back to our sheet here. The base number times the temp number, and they're the same number at the first, right?
Yeah.
So what we can do is we can set
say
our
that
temporary
the base
number
is the temporary number.
Exactly.
But
They hold the same value. Exactly. So maybe right here you might add that statement.
So
temp number is in a variable that's already.
What I need to say, just temp.
Mm-hmm.
Oh, I forgot the M. Is that okay?
The M and the E.
Is that okay? No, it's not.
There you go.
Okay, it recognizes it now. We're good.
Mm-hmm.
Okay. Temp number equals, or it's the same as base number.
Mm-hmm. Perfect.
Do I need to have a semicolon?
You do. Yep.
Okay. Cool.
Okay. Cool.
And so now we're going down here to the to-do step one.
Exactly. Okay. So we have two different kinds of loops we can use. And honestly, you could do either one. I can see ways that you could do what we want to accomplish with either one. But this is one of those moments where we know exactly how many times we want to loop through the loop, right?
Yeah.
We know that it's going to be, we know right here that it's going to be one less than the exponent, right?
That's true.
It's always going to be one less than the exponent, because if we did this with 6, we'd just add another one of those.
Mm-hmm.
And we'd put the 32 down here. And so, because it's an exact number, I would recommend doing a for loop.
Okay, let's do for loop.
Okay.
So we type, let's see, 4.
Mm-hmm.
And are we putting these in parentheses? Is that what we're doing?
Yep, parentheses first.
Oh, not that. There we are.
And then you have 3 things that you're trying to add. You want to create a variable that will count how many times we go through the loop, and that's the first thing. The next thing is the condition that you're looking for. And when the condition is false, that's when we exit the loop.
Okay.
And then we're looking for how you want it to count. What do you want happening during the loop?
Okay. Talking about how the exponent gets involved.
Yeah, how the counter.
The exponent and the base number and all that.
It's actually what happens to your counter. How does your counter count?
Oh, okay.
That's what that third piece is.
Okay.
Okay, so first you want to declare a variable, kind of like you would any other time. You're declaring a variable, so you'll start with your type. What type of variable you want. Whether it's a char or an int or a double.
Is it int?
Or a string. Yeah, this would be an int, and it makes the most sense in this situation. And I've never seen a for loop that didn't use an int. So I'm sure you could try other things.
Okay.
Now we're going to have the variable name. And a common convention is just to call it I for index.
Mm-hmm.
That can be a little confusing at first.
Yeah,
so
sure.
I usually recommend calling it counter when you're first beginning. And then you can work in the I later on.
Okay. And now, is this enough for the first piece?
You actually will want to initialize it, because right now it's just holding a garbage value in it. It's holding whatever was on the shelf last time.
Oh, so we need to say what counter is.
Yeah, what it's equal to. What's the value that counter is equal to?
Okay. So would that be...
Commonly, you'd start at 0.
0, yeah.
Mm-hmm.
Equals 0. right?
Mm-hmm. Exactly.
And do I need to do anything between int and counter, or is that okay?
That's perfect.
Okay.
Perfect right there. Okay, so then you're going to end that statement with a semicolon and start
Okay.
the next statement.
Like we would normally do with a line.
Exactly. Yep.
Okay.
We're kind of squishing 3 lines into one line
with
here.
this one, we're talking about the condition.
Exactly. How do we know how many times to go through the loop?
Would it make sense to have a greater than or
Yes.
less than
Yes. And anything
mark
that can
in here to kind of say when to stop?
Exactly. What we're looking for is something that is true or false. And as soon as it's false, we're going to exit the loop. And yeah. So a statement with a is equal to or greater than or something like that. And commonly in for loops, what you'll usually see is you'll see one variable that contains the number amount times you want to. You'll see the counter, and then you'll see another variable that has the amount of times you want to count. And you'll say, for example, and this is, you'd say counter when counter is greater than.
Forgot your N.
Oh, that's why.
Just like I forgot and switched my E and my P.
Mm-hmm. When your counter is
Means
greater
in
than
them.
whatever the number is that you wanted to exit, like you could write, no. You could write 100, or you can write a variable name in here like exponent, and that's what I'm going to recommend. Exponent in there. And then it will go and it will run the loop
Until the counter is greater than the exponent.
Exactly. So I would recommend doing that. But we know one special thing here. We know that the first time through the loop, we're kind of, because our base number and our temp number are the same, going back over here, we know that the first time through the loop, we're already taking 1 away from the amount of times we want to run through. Does that make sense?
Yes.
Because we have to multiply this 5 times, and we're taking up 2 of them right here.
Yeah.
So we know it's going to be 1 less than our exponent. So we'll need to make this a little bit more complex. So let me prescribe this. Go ahead and put another pair of parentheses in there.
Where exponent is? Or?
Where exponent is. Surround exponent with parentheses. Okay. And then put a -1.
On the inside or outside?
On the inside. Okay. So what that's going to do is it's going to say, when it evaluates this expression to know whether it's true or false, false it exits, true it stays in the loop, it's going to say, okay, what's the value stored at counter? And counter's counting up every single time we go through the loop. So the first time through the loop it's going to be 0, then the next time it's going to be 1, next time it's going to be 3, right? And then it's going to say, okay, so let's replace that with a 3 here. And then exponent, what's the value that the user entered for the exponent? It's, say 5. It's 5. Now let's subtract 1 from 5.
So when it gets to 4.
4, exactly.
Then we stop.
4, exactly.
That makes sense.
Mm-hmm.
Okay.
Okay. And then,
Sweet.
last of all, we need to tell it how we want to increment it. You could say here counter plus 7, and it would start skipping 7. It would count by 7s every single time you go. Or you can just say counter plus plus.
Remind me what plus plus means again.
That's the increment operator, and that just means count up by 1.
Okay.
You can actually even do a decrement operator. You could do minus, and it would go backwards in 1. But you don't need that. And that's actually where C+ gets its name. It's from the increment operator.
C++. Okay.
Okay, and now you're going to pop out of those.
Do I need another semicolon?
I don't believe you do. We'll find out. It will tell us.
And I can clear out this.
Yes, you can. Okay, and now we need to add the actual math inside the loop.
Okay, and this is up to step 2.
No.
No.
We still need. So we've talked about how to enter the loop. What's going to be exiting how we're going to exit the loop. I'm sorry.
Oh, you're right.
But now we need to add the math inside the loop.
We'll just do another line here.
Yes. Yeah. So.
Oh.
You also need the curly brackets, and actually, this is slightly confusing. But if you only have one line of code that's going to follow, you don't actually need curly brackets. You just need to have them right next to each other. But it's just a better idea to put the curly brackets in, so that you don't lose track of where your loop starts and where your loop ends.
And we have a space in between them typically.
Perfect.
As you were saying.
Just like that. Yep.
Okay.
Just like when you're doing if statements. That's not required, but it just looks nice.
So here's our equation.
Okay.
Right?
Here's our equation. Yep.
Okay.
And it's going to be coming from this sheet right here. We're going to have this number times this number, and take that, store it into that number, and move that number down, that times that. Anyway.
So we'll need to use our temporary number in here in our equation. And times, and put the exponent in here, right? Or to take note. I apologize.
No problem.
Okay. So temp number.
I'm going to set that equal to
Temp number. Oh, okay. So we'll say temp number times equals temp number times
the base number. Exactly. I'm sure there's other ways you could do this too. This is not the only way to do it.
And we
But
use this
that's the way
trick.
That
Times.
means that's the multiplication operator.
I'm gonna say base hunter when I see that. Okay.
It makes me want to listen
Is
to some
that
old
it?
techno music. Yep.
Is that
That's
all for
it. That's
here?
all you would need inside that.
Okay.
There is one other step that you'll probably want to do.
Okay.
Because what we're doing here is we're setting by the end of this, temp number is our answer.
Yeah.
But to make it really easy to read, we have answer instead, because temp number doesn't make sense down here. Answer makes sense over here, and temp number makes sense over here.
So do we need to say that they're the same?
Yes, exactly. Yep, we need to set them equal to each other. So you could do that right outside your loop.
And it's okay that it's not before the loop?
Yep.
To set that parameter? Okay. So I just say temp number equals answer equals temp number?
Yeah, that would work. Yep. Equals temp number, because at that point the temp number is storing. That's what we've been doing here. Say that's our temp number times our base number. At first we set base number to that same value, and that's right here, right? And then we're taking temp number times base number and storing it back in temp number, base number, temp number, base number. This is temp number, and now we just need to say this is also our answer.
Okay.
Oh wow, I'm not gonna write that out. You won't be able to read it. Okay. So
Okay,
that's
cool.
what that is. Yep.
Perfect. And so now we're good here. Are we able to move up to step 2?
Let's do it.
Okay. Do you mind if I take away this?
Yeah, go ahead. Yeah, there we go. No, that makes sense.
Okay. Build a loop that asks to user if they want to do another calculation.
Oh yeah, that's not spelled out right. Very well. Wow.
Okay.
Just always do these when we're tired.
So this is where we're actually building our loop, and we said earlier we have a for loop going, but will this be a different loop?
Yeah, I think it would be, because we don't know how many times the user wants to enter in.
That's true. It's kind of a roulette moment.
Yeah, exactly. We could. So a for loop knows exactly how many times you want to go through it, but the user might not even know when they're in this. They can change their mind, exactly. So we just want to give them a moment to exit if they ever want to exit. So this would be a great situation for a while loop.
Okay. So, will this be... Do I need to do any curly brackets?
Yes.
Before I start?
No, not before you start.
Okay.
But it could be useful. Maybe let's start with the curly brackets.
Okay.
Let's decide what part of this code do we want to run over and over again. I don't think it makes sense to do the title over and over again, so I put the title above this.
It would make sense if at the end you ask them if they want to do it again.
That's right. That's true. We did that. And I actually have that popping up. Do you want to enter another loop? Or do you want to enter another... I'm sorry. Do you want to enter another calculation? Y for yes, or any other character for no. So we want this to be included, for sure. And we definitely don't need
the end of the program.
The end of the program to pop up. So
we also need to include our other loop.
Exactly. And then the loop needs to happen again. The math hall needs to happen. Does the user need to enter a new base number? Yeah. Does they need to enter a new exponent? So it probably makes most sense
to put it down here.
Yeah, line 45 probably.
Okay, so that means we would take the last part of it. And put it down here.
Yeah, that makes sense to me. Let's do it that way.
Can I do a space?
Sure.
Or should I just stick it there? Like that?
Yep, right there. You notice how Visual Studio's just indented everything. Yeah.
That makes it nice, because if you're looking for it, you can find it now.
Yeah, exactly.
Okay, so...
And just like the for loop, everything on the while loop is going to be on the other side. It's going to be on the left side of the curly bracket, the beginning of the curly bracket. Okay. So first you need your keyword. Yep.
While.
And then we just have one condition because we don't have a counter in this one, and everything else related to the counter. So now we just need a condition that's true or false.
So, okay, so how are we telling the program to start over?
Exactly.
So, Y for yes. Okay, so this is where we'll say, if Y is typed in, we go again.
Exactly.
So we're going to say that go again equals Y.
Perfect.
Right?
Yep.
Okay.
Now, you would be tempted to just say... No, go ahead. Go ahead and write what you... Go again. Tempted to say just equals. But if you remember correctly, that's actually the assignment operator.
You're right.
So every time the computer reads that, it's resetting.
Ooh.
Yeah, exactly. And that is the comparison operator, or I like to say the is equal to operator. Why? And then...
Do we need to put this in some kind of or some kind of quotation?
Yes, we do.
No, never mind. I thought it was going to... Okay. Is that what we got?
That's what we've got. Now we have some red squigglies.
We do. It's having problems with the C out and our lovely little bracket. Why is that?
Let's go figure it out. An answer, yep. Okay, so let's start off with this first one. Let's kind of hover over it and see what it says.
Main program. It's ambiguous, so it's not... Doesn't understand what that means.
Let's make sure we're using namespace standard. Oh, that's weird. That went away. Okay, squiggly's not important anymore.
Oh.
That was Visual Studio's trying to be helpful, but being too helpful. Not understanding. Okay, but this one's still here.
Oh, we didn't add a semicolon.
That's a problem.
So we need to end this line of code
With a semicolon.
with a semicolon.
Yep. And that one went away. Okay,
Yay.
cool.
Another semicolon
Mm-hmm.
right here.
Right there. Exactly.
That's at least nice that it prompts you.
Any other squigglies? Int answer. Using uninitialized memory. I don't know about that. I think we've initialized it.
I mean, that's a green squiggly. It's a little different than the red squiggly.
Yeah, it's just saying
it's still
best
wrong.
practice. What it's saying right here is you could have a garbage value inside answer. But we're pretty much guaranteed never to have a garbage value because we're setting answer equal to temp number.
Mm-hmm.
Right? So, and temp number is definitely not going to be a garbage value because it's
Based
just
on-
the math performed on base
Yeah.
number. So I think we can just safely ignore that.
Okay.
It's just a warning. It's not an error. It's just a warning.
So is this the point where we test our code?
Let's test our code. Okay, we know our two times or exponents up until at least the 5th power, right?
Mm-hmm.
Because we've been doing that. So let's just use that as a test case. Yes, hit no on that. Using uninitialized. Okay, this is a really good error right here. This is one that we ought to talk about. So let's think through the code. Let's think through the code here. It's setting, so first off, we're entering the main program. We're setting up our variables, which means we're just naming a memory location. We're saying, hey, can you find a spot on the shelf that can hold an int box? And it's saying, yes, we'll give you the access code to that. Is going to be base number. Same exponent, temp, chart, go again. But it didn't clean off those shelves. It didn't automatically put something that we wanted inside that box. There's still dirty shelves there. And so when we go over here, this is definitely not storing a Y, and there's no way it could possibly be storing a Y by this point because we've never asked the user to put something in there.
Oh.
So we'll never actually enter this loop unless out of some lucky shot, whatever garbage value
Is Y.
is already equal to Y. And that would be an incredible lottery win if that actually ever happened. So we can fix that several different ways. One way would be to set this to Y right from the get-go. So we kind of just prime it. And that would kind of fix that problem. The other way we could do this is we could change this whole loop into a do-while loop. And a do-while loop will run the code and then check the condition.
Okay.
And because
That
we're
makes
setting...
sense. The Y comes all the way at the bottom.
Yeah, and since we're initializing our variable, or we're putting something inside that variable right down here in line 44, if we check the loop here, then we're all good.
Okay, that makes sense.
So I'll let you decide. Do you want to do the do-while loop, or do you want to do the initializing?
Let's do the do-while loop.
Okay, let's do that.
So, does that mean I take...
Yeah, you're going to grab that whole expression up to the curly bracket. And you can just cut it, keep it in your...
Let me come...
And put it right up.
here?
Actually, right next to the curly bracket.
Inside it?
Just on the outside of it. Yep.
Oops.
There you go. Okay. And then, just so that the computer knows that you still are in a loop, we need to go back up to the top curly bracket.
Is that okay?
Yeah, that's fine. I actually don't know that you need the semicolon, but that's okay. Let's just run it. Let's see. That's a specific piece of syntax that I'm not sure I understand.
So I want to take it.
Yes. Yeah.
I realized I forgot that one.
Okay.
Okay.
And then on line 18, right next to the curly bracket, on the left side of the curly bracket, you'll want to write the word do, lowercase. think when I wrote it on the whiteboard, Okay. Let's run it and see.
Stop 4.
Counts up. Ill-defined. Counts up from maximum. That's something I should very easily be able to fix, but I can't comprehend what it's asking me to do at that moment. So let's just run it and see if it will let us run. Hey, it let us run. All right.
So we were talking about how we understand the 2.
Let's do the 2. So let's do our base number 2.
Do we say 5?
Yeah, let's do 5.
That's the problem.
That should get 32, right?
No.
We got
You
2.
done messed up.
We did. Let's check and see if our other loop is working, though. Let's hit a Y. Okay, our other loop works.
Let's see. Well, let's try it again.
2.
8. Okay, so it looks like our base number will just always be the answer.
Yeah. So let's go back in and see if we can figure out why it's doing that. Oh, yeah. Hit any other key. And that ended it. Great. Cool. Okay. So we know that our while loop is working, but our for loop, there's something weird inside of it. Okay. So this needs to be true. I'm sorry. This needs to be true. I think we need to have this facing the other direction. So while the exponent is bigger, and that's what it was telling us. That's why we were getting that error.
It's like this won't ever
We're
happen.
still the wrong direction, I think.
Oh, I apologize.
No, you're fine.
Is this the right direction now? Did I just do
I
the
think
same
so.
one?
No, I think you're right. So while the counter is smaller than the exponent. Yep. Now click outside of that somewhere. Okay. Let's just see. Let's see if it runs.
Yay!
Hey,
That fixed it.
There you go.
Okay,
That was it.
So yes, we want to continue. Let's do 6.
So it was just never entering the loop.
Just because it was never a true statement.
Exactly.
It was
always a false statement. Check your terms and conditions. Beautiful. It runs exactly the way we'd expect it to.
Nice. Oh, and look, the 4 is gone.
Yeah, the little squigglies.
Squiggly.
Yep.
Okay, high 5.
Nice work.
Nice job.
Yeah, we are 5 weeks in, and you've already built the calculator.
Stumbling through. But we're doing it. Thanks.
All right, this is where it's really going to prove that one programming language might be good at one thing and another at another. JavaScript is going to be a little weird, but it's going to simplify a couple things. The first thing I want you to do is when you open this window in Play Code, go and change this. This will probably say something like 3 or 4 or 300 or 3000. Change that to a 0. And that is going to make sure that it lets us run our whole loop. Okay, I'm going to copy and paste some code that I prepared in a different IDE. Actually, I already got that. And I'm going to Control V to paste. Control V to paste it in. Okay, and here's what I've done. Now that we've talked about loops, we can do something pretty nice. If you've worked with JavaScript and you've used this playcode.io, you'll realize that it's just a little bit awkward. It's awkward because anytime you try to get input from the user, we're using prompt. Prompt is fun because what it does is when we start the JavaScript code, it actually starts looking for these prompts first, and it wants to do all the prompts at the very beginning of the page before it even loads the page. And that's just the way that JavaScript is set up. The problem with that is as soon as we are making any change to the code, it starts prompting us all over again. JavaScript is just like that dog. You throw the ball out, it grabs the ball and runs right back and wants to play again. That's exactly what it's trying to do. And it's all just this play code environment. If you were programming a website, which is what JavaScript is meant to do, it would feel and act a little bit differently. But because I don't want you to be bogged down by learning CSS and HTML and all those other programming languages that you need, markup languages that you need for the web, we're just going to try to make it work in this wonky little play code environment. So what we now have, now that we've talked about loops, is a way to mitigate, a way to delay those prompts from coming right to us. So what I've done is I've created a variable, and any variable that we're going to create in JavaScript, we're always using the keyword let instead of saying int or string or anything like that. We're going to say let, and we're going to let JavaScript choose what kind of variable it is. Okay, so I'm going to say let, my variable name is start, and it's going to store the char no, or n in it. Okay, then I'm going to say whenever start is equal to y, then run all of my code. And I'm just putting my whole program in there so that now I can say start or stop. So let me show you. I'll show you how that works in just a second. Let's run through this code for just a second. It looks like very much like what we just did. In fact, I kind of copied and pasted our C++ code and just adapted it using things that you would do in JavaScript. For example, no cout. Instead, we're using console.log, but the expression inside is very similar. Instead of using cin, we're using prompt. And this is the message. This is how we say that we want to prompt something, and this is where the information that we're prompting gets stored. Still setting temporary number to base number. The for loop is not really any different, except I don't need that semicolon in there. You don't need semicolons in JavaScript. You can have them. They don't hurt, but you don't need them. We're still setting answer to temp number. We're still displaying all this, but we're doing it through a console log statement, and instead of having wakas, we have plus symbols. But it's set up the same way. And then I simplified the prompt for going again. Now the problem with this, and there's some things that we can do to fix it in a normal JavaScript environment, but to keep it simple, we're just going to assume that the user knows how many exponents they want to do beforehand. And so we're just going to say, instead of say go again, let's say would you like to enter another number? Okay, there we go. Y for, oh, I've got to escape these out. See, when I put that, since I'm using single quotes here, when I put this other single quote in here, it thinks I'm ending the text instead of saying, instead of having quotations within the quotation. So all I need to do is put a backspace there and a backspace there, and it will, it's called the escape symbol. It will escape those out, or just basically these backspaces are just saying, hey, don't look at this as an end to my quote. Instead, look at it as part of the text of my quote. There we go. For yes. And now I can end my quote. Okay, there we go. And then it's going to check this is still inside the do while like we had. Syntax is all the same for that. Okay, and then at the very end, after, just to make it, stop it from going right back in and doing an infinite loop, I'm going to stop my program by saying start equals no. And that way when it gets back up here, it's like, oh, okay, we don't want to run again. So how are we going to start this program in this crazy environment of playcode.io? We are going to change this to y. And now that's true, and see, it automatically started. Okay, let's say 2 is our base number. Our exponent is 5. Would we like to enter another? Sure, why not? Let's go ahead. So we're going to hit y for yes. Okay, now our base number, 5. Okay, and 3. Would we do another? Sure. How about, let's just find the square of 32. So 32 is our base number. 2 is our exponent. I'm going to just say, no, I don't want to do any more. And then it prints it to the console. So yeah, that's a little awkward. It doesn't work quite the same way that C++ does. But we did solve a very annoying problem. And as long as the user knows beforehand, this would work perfect for them. In a real environment in JavaScript, you'd be able to mitigate that. Be able to change it differently so that it doesn't awkwardly ask you right off the bat. Okay, so let's go ahead and go look at Kotlin. Okay, let's take a look at it in Kotlin. Just a few things to note. This is not the way you write code in Kotlin. You definitely are trying to write as few lines of code as possible, and so we'd probably want to declare these down where we're going to use them in the for loop or in the do while loop itself. However, I did want to show you one thing that I learned. You remember that Kotlin is like JavaScript, and it kind of makes the decision for you what type of variable you have here. However, you can and actually are required to specify what kind it is if you don't have a value to set. So let me explain that a little bit better. So when we declare a variable, we're usually going to initialize it with a value, say 0 there. But if we want to not initialize it yet, what we would do is we put a colon and then the type right after that. And you can use that as a way to specify a variable that you just want to be able to make the decision on. You don't want to hand that decision off to the language itself. You can make the decision for that variable with that colon and then the data type. And then the other thing is data types are capitalized in Kotlin. So don't make the mistake of saying int like that, because that's not an int. That is an int as far as Kotlin's considered. Okay, and then the other thing, we have been using this integer.valueOf readline. This is all kind of, it's really similar to what you need to do in Java to get a value like that. And that makes all sorts of sense until we need it to be a character. What I found was that instead of doing a character like character dot value of, instead of doing that, a better solution when using readline is to do readline exclamation point, and bracket. And so that's really what it's saying is grab the first letter in the string that's coming back and convert it into a char that's going to get stored in Go again. And so that's what I learned. The other thing about this that's going to be kind of different is for loops. For loop syntax is so much simpler. They kind of assume that you're already going to iterate through a bunch of things, so you don't have to put that I in there for index or iterator. Instead, what you're going to say well, okay, you do have to put it in there. You're just not going to put it in as a new variable that you're creating. Instead, you're going to say, okay, for I, what is the name of our iterator? What's the name of our index? In, and then you'll put a range of numbers. And it's okay to start at 1. There. So 1, and then dot, dot, and then you'll put the other number. So normally, if I was just going to say, I want to run this 10 times, I would say 1 to 10. Let me type that in correctly. Okay, 1 to 10. And that's what it would be. Or you can put your variable in there, and remember to make sure that our variable is actually showing the correct exponent, because that first time it's times itself kind of gets rid of one of our rows. We have to do this exponent minus 1, and that's what gets us there. And then you could put the brackets in if you had multiple lines, but if you only have one line, Kotlin just wants you to put it all on the same line with it. So directly after, no brackets or anything like that, just put it on the same line, and that's your code. That's the whole for loop right there. It will run this as many times as the exponent prescribes. Okay, and then we're just doing exactly what we've done in all of those other examples, just in Kotlin. The do while loop syntax is exactly the same as the other languages. And there we go. Let's run it and just see what it looks like. So you can go up here to run, and you can hit run. You also have the option to right click on that and say run. Or what you can do also is hit Control F5, and that will run it. Okay, so here we go. We're down in our console. Let's add the base number of 2 and add an exponent of 3. We should get the answer 8 from that. And there we go. There's the answer 8. Do we want to go to continue? I would say yes. Let's do another one. Okay, let's do base number of 5. And let's cube it. And there you go. Perfect. Okay, let's do an insane number. Let's go 80. I just want to see what kind of overflow we get. Or does Kotlin take care of all that? 80. And let's say 80 times, let's put 20 to the power of 20. What kind of a number did we get? Oh, yep, we definitely had some overflow there. Okay, well, cool. There are limits, apparently, and there are ways to get around those, but for now, that's a pretty nice little calculator. And even your calculator has limits as well. Everything in digital world has its limits. However, we're constantly pushing those limits and finding ways around it. All right, there we go. Thank you for joining us for this week.